Okay, I'm getting a lot of requests for help on project one. And since it is due tonight, which I will extend to tomorrow, that doesn't give me a lot of help for a lot of time for back and forth to help everybody by email. So I'm going to post this as a help for everybody to try to get people started. And I'm going to extend the deadline to tomorrow night. So you have a chance to ask me questions during office hours or over email. It's a little bit slower to go back and forth. So to get you started on these, for project one, we went over the first one. We went over a similar problem to this back at the end of the live session in 9.1. So there's two different things. There's three different, like basically three different wheels. So if you have two things that are connected, I'm going to exaggerate this like this. Okay. So let's say this one is R1. This one, has radius 1. This one has radius 2. So we'll call this one wheel 1, this one wheel 2. And they're connected either by some sort of chain, or this could also be a case, I think in the homework, where they had teeth, like this. Okay, so the teeth are, those are my lovely teeth right there. Okay, so the thing is however much the chain moves on one, it's going to move the same amount on the other. Okay, so if they're connected, your arc length is going to be the same. So if this moves like 3 inches around this circle, then it's going to move 3 inches around this circle. And then same thing on my teeth drawing over here. If it moves through 3 inches of teeth here, it's going to move through 3 inches of teeth here. So the key to these is that the arc length is going to be the same. Okay, so here we've got S1 equals S2, okay, for wheel 1 and wheel 2. So that's going to mean that R1 theta 1 is going to be equal to R2 theta 2. Okay, because remember, arc length S is equal to R theta in radians. Okay, so this has to be in radians. All right, so if you have two connected wheels, that's the key, is that the arc length is going to be the same. All right, two wheels like this. So just for example, I'm not going to give you the one that's on the project. Let's say that we know, so this one has theta 1, this one has theta 2. Let's say that we know that theta 1 is, let's say pi over 2, and we know that theta 2 is pi over 6, and we know that R1 is 3 inches. Okay, so I would take the information that I would know and I would put it in here. So R1 theta 1 is equal to R2 theta 2. And I would put that in there, and then I would solve for I would solve for the one that's missing. So for this one, it's R2. So I've got 3 pi over 2. I want to get R2 by itself. I would multiply by the reciprocal, 6 over pi. And that would give me 18 over 2, which is 9. So my radius 2 is 9. Okay, so the one in the project is different numbers than this. And the other thing that you need to know for the one in the project is that it tells you one full rotation. So remember that one rotation, we talked about this in the definition, is 360 degrees or 2 pi. So that's the other thing that you need to get through number one. 1A, I guess would be that part. Okay, so hopefully that gets you started. The second part of number one is you've got another set of wheels. So, okay, so this is where you have the cassette to the bike, is the part with like the little knobs on it and stuff, and then that's attached to the tire. They are bolted together, meaning that they rotate the same. So for this one, you had R2 and you had R3. That's not showing up very well, is it? Let me try that again. Should make that a little bit more visible. Okay, so it was like this where you had R2, and then you had like this was R3. Okay, for this one, because they're bolted together, if the second wheel moves, the third wheel moves the same amount. So for this one, theta 2 equals theta 3. Okay, because they have to rotate the same amount. They're bolted together. So hopefully everybody sees the difference here, and when the arc lengths are going to match because the wheels are connected, and when the angles are going to match because the wheels are connected. I think the people that are not getting number one right are trying to do the angles matching over here, and that's not going to happen because the two wheels are are different sizes and they're connected by a chain. Okay, so if you can get number 1, then this information, or A, then this information should give you part B, and then hopefully you can get the rest from there. All right, then for number 2, a lot of people are kind of on the right track that they want to use the area formula or circumference formula, whatever, but you want area of a sector. So in our book, we did area equals, let's see, it was theta over 2 r squared, where theta is in radians. Okay, so in class and in the homework, this would have been what you had used, was theta over 2 r squared, where theta is in radians. There's another formula that is theta over 360 pi r squared, and this is for theta in degrees. You are welcome to use either one of those formulas. They're easily Googleable. You can use either one, and that should get you started on number 2. If you're doing the full area, it's not going to work because one only does 90 degrees and one does 60 degrees. So you have to do the area of a sector. And then once you have the area of the sector, then you can move on to the next couple of problems. Okay, so whichever way you want to do it here, what this is doing is just giving you part of the full area. So area is pi r squared. So this one gives you the portion of the area for theta in radians, and this one gives you the portion of degrees, and then you multiply that by the area. So those two should get you started for number 2. If you still can't complete project 1, I'll be online tomorrow at 11 a.m. for my normal office hours. If anybody needs help and can't come at 11 a.m. because you're in work or school or whatever, I can also be online at 6 p.m., but I'm only going to do that if people request it. I don't want to block out another section of time and then have nobody show. So I can be online at 6 p.m. if anybody would like for me to be at that point if you haven't gotten the project and the homework done. Okay, so hopefully that gets you guys started. And even if you don't get it finished on time, you can still turn things in. You can turn in projects and homework and weekly checks late for 10% less. So keep trying. I hope nobody gives up. Keep trying, and hopefully that gets you going.